In this video we're going to discuss CRA models for rational number conversions. So we're going to start with a fraction of 1/8 and showing how we can convert this to the decimal of 125 thousandths, and then we're going to start with 125 thousandths and show how we can arrive at the fraction notation of 1/8. So I'm going to show the concrete models and the abstract models. Those are going to be the most common, just because the representational ones get to be a little tedious and a little messy. But if you do want to do the representational with the drawing, you would just use those kind of drawing representations of your base 10 material. So we're going to start with 1/8 is equal to 125 thousandths. Okay, so again, kind of to start going back to what this fraction notation means. This 1/8, it means that a whole has been divided into 8 equally sized parts, and we just have one of those parts. We want to know what the size of one of those parts is. Okay, so we're going to get to this decimal, we're going to start with one whole. We're going to divide it into 8 equally sized parts, and then we're going to look and see what is the size of one of those eighths, because we just want 1/8. Okay, so for this representation, since we're going down to the thousandths, we're going to use this larger cube as our representation of 1. So this is one whole. Okay, so we're choosing this because it has 1,000 tiny cubes, and our decimal point will go down to the thousandths place. Okay, so our first step is to divide this into 8 equally sized parts. So for this, since we just have one, right, we need to ungroup this. We can't put ones into each of the 8 groups equally, so we need to ungroup or regroup or trade this for 10 tenths. Okay, so these will just be your square pieces here. Okay, so 10 tenths, so we're going to trade that out. So we still have the exact same quantity, but now we can actually start dividing this into 8 equally sized groups. Okay, I'll try to get all 8 in the frame here. So just each of these is going to be one of my groups. A little closer. Okay, so I have 4. Okay, so far I have 8 groups that each have 1/10. Remember, each of these is 1/10 of our whole, which was that larger cube in this case. But I still have 2/10 that I still need to divide into each of these 8 groups equally. So since I can't place these into the groups without making them unequal, I will need to exchange these 2 pieces for hundredths. So instead of having 2/10, I need to have 20 hundredths. Okay, and that will be 20 of your kind of your long strip pieces. Okay, so here's our 20 hundredths. Okay, so we have 20, so we can start, if we wanted, we could go one at a time, but we know that we can put 2 into each. I'll have to stack these just for the sake of room for the video frame. But so we can put 2 hundredths into each of the 8 groups. Okay, and then I'm left with 4 hundredths. Once again, I can't distribute these 4 into these 8 groups equally, so I'll need to regroup these or ungroup these into thousandths, so kind of breaking these on these break lines. So I'll need to have 40. Can't keep these quite lined up. So hopefully I counted these accurately, but so 40 of these thousandths. Okay, so 40 of those small cubes. Okay, again, we could go one at a time, but just for the sake of time here, we know that we'll assume that we know if we have 40 cubes and we want to divide them into 8 groups equally, we can put 5 into each. right, so from our starting point, right, this was our 1 whole. We divided these into 8 equally sized parts. Remember that we got that from the denominator of our fraction. So then we want to look at what is the size of one group. Okay. So I'm going to just kind of slide these over just focusing on this one. Again, in relation to our whole, which was this larger cube, and we can look back. All right, we have one of these kind of larger squares, so each of those is representing a tenth, so that's why we write a 1 in that tenths place value spot. We have 2 of these strips, which are representing hundredths, so we have 2 hundredths, so that's why that goes in the hundredths place value spot. And we have 5 of these tiny cubes, which represents a thousandth. So then we have 5 of those, so we have 5 thousandths. So that's why we can convert this fraction of 1/8 to the decimal 125 thousandths. Okay. And then actually for the decimal to fraction notation conversion, I want to give just a couple steps just to give some background first. So whenever we have a decimal, remember a decimal is just a special type of fraction. It's just a fraction where the denominator is some power of 10. Okay, so by a power of 10, I just mean it's 10 to the first power, 10 to the second power, 10 to the third power, and so on. So we can always, as our starting point, rewrite this as 125 thousandths, right? That's how we would read this in decimal notation. So we have 125 out of that total 1,000 pieces. Okay. So from here, I'm just going to do this in 2 steps, but I want to show this abstract model first, and then kind of go back to the concrete one. So again, what we're going to be doing, right, because we just want to find an equivalent fraction to 125 over 1,000. So we'll eventually arrive at an equivalent fraction, which is 1/8. So in order to find equivalent fractions, we can multiply and divide the numerator and denominator by the exact same value. That's the equivalent fractions algorithm. So this first step I'm going to do, and you could break this down into multiple steps if you, or more steps if you wanted to. But this first one we're going to do is just to divide both by 25. Okay, both numerator and denominator by 25. Okay. So again, if we're doing 125 divided by 25, right, that means we're going to take this quantity of 125 and divide this into either groups with the size of 25 or into 25 groups. Okay, so I'm going to just kind of focus in on this one on the top left here. So I'm going to move some of these over. Try to keep this on. Okay, so what we're doing, again, when we're dividing this by 25, and we're just focusing on the numerator right now, 125 thousandths, right? So a thousandth is one of these little cubes, so we have 125 of those here. So if we want to divide this by 25, I'm just going to say we're going to divide this into groups with a size of 25. Okay. So we can make one group with a size of 25. I'll actually align these vertically here just for space. Okay, so that's one group. So this will need to be subdivided or broken down. Right, so instead of having 100 of those thousandths in these in this square, right, we'll want to exchange this for our hundredths. Okay, so we'll have 10 hundredths instead of that 1/10 here. Okay, and I'm just going to put 2 of these. All right, we're going to do groups with the size of 25 thousandths. So then these I'll also, rather than having 20, or these 20 cubes all kind of compacted into these 2 strips, I want those individual cubes. Okay. Now I should need to take some from here. So when I started with that 125 thousandths and I divided that into groups of the size of 25, all right, you can see I have 5 groups there. So that was just the numerator. For the denominator, right, I'm not going to break this one apart, but we're just going to kind of think through this. So if we had 1,000 pieces and we want to divide this into groups of the size of 25, all right, first looking at our face, right, there's 100 here. So 100 divided by 25, we know there'd be 4 groups, so you can kind of think of just a cross, kind of vertically and horizontally in the center, so there'd be 25 in each of these 4 corners. Okay, so there's 4 groups of 25 right on this face, and then there's going to be 9 more faces that are identical to that. Okay, so we'll have 10 groups of 4, or a total of 40, and that's what we would find if we do that 1,000 divided by 25 as well. Okay, okay, so now we have 5 of our groups, and again our whole would have 40 groups, and then again we'll need to divide each of these by 5. So here now we're thinking of each of these stacks as one object now. So I'm going to kind of put them a little bit tighter. Okay, so we have our 5 kind of objects here, but we want to create, remember we're dividing by 5, so we want to create groups with a size of 5. So actually now this entire quantity will just form one group that has 5 of these individual pieces in there. Okay, so this is all one group. And then kind of similarly, right, so there's 5 objects in these groups now, and each of those objects contain 25 thousandths. So you kind of think, right, we had 1, 2, 3, 4 groups of 25 on this face, and then we can take one more, let's say kind of this corner piece from this one. Okay, so that'd be one group of 5 of those objects with the size of 25. Okay, and as we'd kind of do that and continue to move through this cube with the size of 1, we'd find that there's a total of 8 groups of that size in the whole. Okay, so that's kind of kind of a repeat of showing how that equivalent fractions algorithm works for division, but that's how we can then arrive back to that fraction of 1/8. So this is kind of a example of how we can use those base 10 blocks as a concrete model to kind of show these abstract models from either starting from a fraction going to a decimal, or starting with a decimal and going to a fraction. And again, if you want to use the representational model too, which those aren't going to be quite as common, since there's kind of a lot of moving parts, especially when you're down to the thousandths place. Again, it would just be drawings that would represent some of these base 10 blocks.